What's up, kids? Mr. Cully here, and today I'm going to explain to you the Conductivity Lab that we're doing in class. So I'm just going to kind of summarize what's going on, and then we're going to discuss it as a class together. So what we got here is we're building a circuit. So if you know anything about electronics, wow, my hair's messed up. It's all right, it's 6 in the morning. If you know anything about circuits, what do you need? Well, you need a power supply, you need some wires, you need something that you're going to run, so like a fan or a light bulb or something that is going to take some of that energy and use it for something. So in this case, we've got a 9-volt battery, we got this fan that's connected to this little motor, and we got these alligator clip wires, which are just wires, little clips at the end. All right, so can we build a circuit out of this? Yes, we can. All right, let's take a look at what we're going to be doing. Here's a close-up image of the motor. So you can see that there's two little sides. I'm going to call these terminals, basically. They're just two different sides where we're going to allow the, you hear that voice crack? We're going to allow the electricity to kind of move through. All right, so one alligator clip's going to go to one end, the other is going to go to the other end, kind of like this. All right, so we're just connecting our wires so the electricity can run through the motor and power the fan. All right, so let's say, all right, we got this. We got this wire over here, and we've got these two alligator clips. Well, if we connect it to the 9-volt battery so we complete the circuit, then the fan is going to run. All right, fair enough. Yes, we could probably understand that part of it. So the battery, you connect each one of the alligator clips to each of the terminals. It runs through the motor, and bada bang, bada boom, you got a working fan. Kind of cool. All right, so something that you probably maybe not have worked with before, but maybe you've seen in your garage is something called a multimeter. And what this can do is it can read a lot of different things regarding electricity. So we're not going to go into all those, but you've probably heard of voltage before, you've heard of resistance, and you've heard of amps. Okay, that's current. So we're actually going to be dealing with current right now. We want to see how much current is going through this circuit. All right, so the way that I have it set up right now is the way that we're going to be using. And it's got these two little leads that kind of go through. So current actually goes through. We can set it up so that this multimeter is within the circuit so we can get a reading for how much current is going through. All right, and that's just a close-up view of what we're working with. So we're going to keep it on the 5 amp setting, which just means it can read up to 5 amps. And here we go. We got our different wires coming out of it. So let's take a look. All right, now we've got the same circuit. So it's the battery connected to the fan, but it's going back through this multimeter now, all right? And the whole point of that is just to get a reading, all right? That's the only point. So the only way we changed the circuit so far is that we have kind of put a multimeter in it so that we can see how much amps are running through the circuit. And if you look, it says 1.70. So there's 1.70 amps of current going through the circuit, all right? You're like, does that have any significance? I'm like, no, it doesn't yet, but it's just cool that we can get a reading from it. All right, so let's say that we break the circuit. We unclip the two bottom clips, and instead we kind of put nails at the end. If we touch the nails together, should it light the circuit? Well, this is what we have right now. You can see that the circuit's broken because we've got these two iron nails. They're not touching each other. There's nowhere for the current to flow. It's got a reading of 0. We got the fan over here. All right, but what if we touch it? If we touch the nails together, you can see a little spark, and yes, it's forming a connection that's going to close the circuit and allow electricity to run through it. So you can see how that works. All right, but all right, let's try something different. So let's put these nails in a beaker, not touching each other. Okay, so right now the beaker's empty. The nails are not touching each other. Can we form a circuit without them touching each other? Let's see. All right, so right now we've got a reading of 0. Let's fill it up with just tap water. So right now we've got tap water. You can see it's just kind of filling it up to a little over halfway of each nail. Do we get a reading? Very, very small. Huh. Why do we get a reading at all, though? That's interesting. Let's put some sugar in it. Let's see if sugar changes anything at all. So that's just sugar. So we got 0.02 right now, amps. And we're going to put sugar in it. All right, fair enough. It didn't go up. It's always good to stir. Why do you stir things? Think about it. Why would you want to stir? Why does it help dissolve anything? All right. And it's still 0.02. So sugar does not change the conductivity of the water at all. Interesting. Let's try salt. So salt's a little bit different. Let's try salt now. Put salt in, just a little bit. You start to notice that one of the nails looks a little bit different than the other. And it got a higher reading now. Okay, so we know that salt's kind of doing something. If we stir it up, let's see how that changes anything. All right, you can kind of see what's going on there. Oh, much higher reading. All right, fair enough. Fan's still not going though. Let's just add more salt. Why not? Add a ton of salt, stir it up. Interesting. Okay, much higher reading. Fan's still not going though. Just pour all the salt in. You can see that the water is starting to look different. And you can see the fan starting to go. All right. And now we're up to 0.67 amps. And the nails are not touching each other, but you can see something's going on. The more salt you add, something occurs. Why would salt matter? Let's just put all the salt in there. Oh, yeah. That's disgusting. All right, 0.87, 0.88. Fan's starting to go a little bit more. All right, fair enough. So what's going on there? Think about it. What's going on? All right. So that is the salt solution after, okay? After we kind of run electricity through it. Now we're looking at, this is if you let it run for a while, this is kind of what it looks like. Let's take a look at what it looks like if you were to take it out. If you were just to take out one of these nails. That's so cool to me. What the bejeebers is going on? All right, still hitting like 0.8 amps. And that solution's starting to look a little disgusting. You can see what happens to the reading when you take one out. All right. So think about what's going on there. And yeah, that's a picture if you just let it run. Oof. Okay, let's try something different now. So clean that out. Here we go. Now we got a fresh beaker. Let's try something new. Some vegetable oil. Okay, let's see if that does anything. All right, already looks a little bit different. Zero conductivity, absolutely nothing going through the circuit. All right, so vegetable oil is a little bit different. But what if we touch the nails together in the vegetable oil? Okay, then it goes. But they have to be touching for it to complete the circuit. That's different than before. Okay, fair enough. All right, so let's say that we got a little bit of oil and we put a little bit of salt water in it. So now we got oil and salt water. All right, so they're separating. You got the oil on top, you got the salt water on the bottom. This should be interesting. Okay, so that's our setup. We don't have the other nail in yet. Let's see what happens. All right, so now it's just poking through the oil. Nothing yet. Now it's poking through the salt water. Okay. All right, pay attention to what's happening with the oil touching the nail and the salt water touching the nail because it's different. All right. So now we got the fan running. It's like a lava lamp. Okay, so that's what we're going to be doing. And those that are in class, what they're going to be doing is they're going to swap out the motor for a beeper. This is all that is, and a light bulb to see, how it changes things. But so that's the lab that we're doing in class. Here's what I want you to think about. All right, why did the tap water have any reading at all? Think about what you know about tap water. Why would it conduct any little bit of electricity? The sugar water. Sugar is a covalent compound. Why would it not conduct electricity at all, no matter how much we added? Salt water, on the other hand, we noticed that something definitely happened when you put salt water and you ran electricity through it. Think about, why would salt water conduct electricity? Also, was there any evidence that a chemical reaction was taking place? What was that? And then lastly, we just did the oil. What do you know about oil? What kind of compound is oil? So I'm going to post this lab, and I want you to think about it. We're discussing it together in class.